So, hello students, how are you? This chapter is going to be complete, and the one topic only remain now, that is magnetic properties in solid. Last two lecture was based on the electronic concept, the semiconductor and band theory, which is the one of the most important topic in this chapter, solid state. I hope you learned well, and if there is any doubt regarding the topic or any other topic, you can ask me anytime at comment box. We'll try to explain instantly. The other thing, I also provided a solid state notes in the last lecture in a description box. I hope you all are go through that. So let's start the topic, magnetic properties. Actually, magnetic property, if I start from the beginning, where the magnetic properties, magnetic orientation or a magnetic behavior originated or started, the beginning thing is the moment of electric field. The moment of electric field always induce some kind of magnetic field around. The magnetic field is actually depend upon the movement of electrons and sometime movement of nucleus at their own axis and movement of electron around the nucleus. There is two different types of magnetic behavior in any single particular atom. This is due to the electronic movement at own axis, electronic movement around the nucleus, and nuclear movement at the own axis. So these three different kinds, actually the two for the electron and one for the nucleus, this movement of the charge actually reason for the magnetic behavior of any single atom. Magnetic behavior of any single atom. We will dealing with the magnetic properties, so we have to learn actually what is the reason, what is the cause of magnetic behavior in any single compound, molecules or atom or ion. This is always because of the electronic moment or a nuclear moment, means moment of positive sphere or moment of electron or negative sphere. So always these moments responsible for the kind of magnetic property in the substance. Always. One other thing, the electronic moment may be different type. Actually, the electronic moment depend upon the directional orientation. So suppose there are two different electrons and one electron move towards the clockwise and one electron move towards the anti-clockwise. So they together spontaneously, they together actually cancel out the magnetic moment of the particular region, causes no magnetic moment at that time. So it may also be the electronic moment cancel out the magnetic behavior at the region at the time. That time the substance will not show the magnetic behavior. The other thing, when we are dealing with the magnetic behavior, magnetic properties, whenever we are recalling the magnetic behavior, it is depending upon what is the nature of magnetic substance, what is the nature of substance in magnetic field. What is the nature of substance in magnetic field? Is there substance behaving like an attractive nature, repelled by the magnetic field, or attracted towards the magnetic field, or there is any no response in a magnetic field? It also may be the substance magnetized temporarily or permanently depending upon the magnetic field. So all this termed indicated the different kinds of magnetic behavior in the substance. We always dealing with these all the property. But before starting the topic, you have to be learn first thing. The magnetic behavior is actually depend modernly or majorly depend upon the electronic moment, negatively sphere particle or positively sphere moment, and which causes a kind of dipole moment in the substance. Dipole moment is always a moment of charge, arises due to the moment of charge. If there is any electronic displacement, electronic moment so they may cause a type of dipole moment at the time, and that dipole moment may causes permanent or temporary magnetic behavior in the substance. So with the help of these compiled topic, we can now discuss about the different types of magnetic behavior in the substance. So first, we can differentiate in the on the basis of two different topics. If the substance having completely filled orbitals, if the substance, atom, molecule or compounds having a completely filled orbital, or the second thing is if the substance, atom, molecules or ions having a some unpaired orbitals. Unpaired orbitals means unpaired electron is there. So on the basis of completely filled, completely paired orbitals and some unpaired orbital, depending upon these two things, we can differentiate majorly the magnetic behavior into two different types. If the substance having completely filled orbitals and only paired electrons are there, the substance is known as diamagnetic. The substance is known as diamagnetic properties. The diamagnetic property means the substance generally weakly repelled in magnetic field. When these substance bring in a magnetic field, they weakly repelled by magnetic moment, magnetic field applied, because there is no any electron unpaired at the time. All electrons orbitals are completely paired. So due to which there is no net magnetic moment arises. Completely filled orbitals, magnetic moment is zero, and due to which the substance known as diamagnetic. And for example, vanadium pentoxide, titanium dioxide, sodium chloride, water, benzene, and all those atoms having completely filled orbitals. No unpaired electron is there. So students, diamagnetic always meaning the substance having a completely filled orbitals, and whenever these substances bring in a magnetic field, they will be repelled by the magnetic field applied. Due to the completely filled orbital, there is no any net magnetic moment arises at the time. In spite of that, some other substance may have some unpaired orbitals, some unpaired electrons, which is responsible for some magnetic behavior, small or large not matter, magnetic behavior in the substance. They are said to be a paramagnetic. They are said to be a paramagnetic. Generally, these substances having a unpaired electron in a less in a number, and when these substances bring in a applied magnetic field, they weakly attracted in a magnetic field, and due to the presence of unpaired electron, this is the reason spin magnetic moment. The magnetic moment due to the electronic spin is not zero. Actually, there is a completely filled orbital in diamagnetic. So the spin magnetic moment arises by a single electron is cancelled out by the other electron because of the pairing of electrons is there. But in paramagnetic, you know about, there is at least one are more than one unpaired electronic orbitals are there, so the completely spin magnetic moment will not be cancelled out, and due to which the submagnetic moment, the spin magnetic moment due to the electronic spin always present, which is responsible for weakly attraction whenever these substances bring in a applied magnetic field. Oxygen molecule, the unpaired electron in anti-bonding pi orbital. Anti-bonding pi orbital. Copper plus 2, Fe plus 3, titanium trioxide, titanium oxide, vanadium dioxide, copper oxide. You can see these are the some metallic transition metal oxides, some iron, and molecule like oxygen O2, sulfur S2. These are the some example in which at least one or more than one unpaired orbital present. Reason spin magnetic moment is not zero, causes a paramagnetic behavior. So these two magnetic property actually based on the electrons are paired or unpaired, but at the same time we are dealing with some other magnetic behavior of the substance called ferromagnetic, antiferromagnetic, and perimagnetism. So first, to explain all these three, I mention one thing. All these three are actually a kind of paramagnetism. Ferro, antiferro, and perimagnetic are the kind of paramagnetism. All these three having a unpaired electrons only, and they may change into the paramagnetic behavior at the certain temperature also. Means ferromagnetic, antiferro, and perimagnetism may change into the paramagnetic behavior at certain temperature. So they always change towards paramagnetism because of the unpaired electronic orbitals. But what the actual basic difference among them? For that we have to learn this word domains. Domains, a teeny magnets, tiny, sorry. Students, actually in a solid state, the metallic crystal, metallic lattice having a metallic positive sphere which grouped together at a particular region, the metallic ion, metallic sphere grouped together at a particular region and behave as a tiny magnet. Behave as a tiny magnet. They are said to be a domains. They are said to be a domains. It is very important to learn. The domains means a tiny magnets already present in the solid crystals because of the grouping of some metallic ions or metallic positive sphere at a particular region. So at a particular place, the different metallic sphere, positive sphere group together and act as a tiny magnet called domains. So we will deal with now that word domains. At a normal condition, the domains are abruptly or randomly oriented. No any single or particular direction is there. At a particular condition or normal condition, when we study the solid of the different substance, the domains are abruptly or randomly oriented. But when a substance bring in a magnetic field, the domains may oriented in three different types. The domains may set or ordered in a three different types. If all domains are oriented in a same direction, a parallel direction towards magnetic field, Have you listened? If all domains in a magnetic, when we bring a substance in a magnetic field, if all domains oriented parallel in a same direction towards magnetic field, due to which there is a strong magnetic field originated in the substance in the given presence of magnetic field applied, due to which the substance become a permanent magnet. A substance become a permanent magnet. And when we remove the external magnetic field, the substance remain in a magnetic behavior. The substance remain in a magnetic behavior. I am repeating once again. So some of the substance when bring in a external magnetic field, if all domains which is abruptly or randomly oriented before in a magnetic field oriented in a same direction, a parallel direction, and due to which there is a strong magnetic field arises and substance become a permanent magnet. And substance become a permanent magnet. So they strongly attracted towards a magnetic field because of the parallel orientation of domains, and net magnetic field become very high and they become a permanent magnetism. They become a permanent magnetism because of the parallel orientation which sum up together and causes a strong magnetic behavior in a substance. This kind of substance known as ferromagnetism. This kind of substance known as ferromagnetism. For example, iron, cobalt, nickel or chromium dioxide. Some of the typical examples are there. Iron, cobalt, nickel or chromium dioxide. They act as a permanent magnet due to the parallel orientation of parallel orientation of domains. I am writing one word also, Curie temperature. Learn this point and if possible note down also Curie temperature. The temperature above which no ferromagnetic behavior observed, the temperature above which no ferromagnetic behavior observed is called Curie temperature. So this temperature depending upon when no ferromagnetic behavior observed. So at a certain temperature or above which the ferromagnetic behavior substance showing no any further ferromagnetic behavior, no observation of ferromagnetism. So the temperature is called Curie temperature. Okay, the opposite of ferromagnetism is called antiferromagnetism. So what I taught, I was teaching the orientation of domains. The orientation of domains, if all orientation in a same set of parallel, they are said to be a ferromagnetism. But it is also possible some of the substance in an applied magnetic field behave as the parallel, antiparallel in an equal set of number. In an equal set of number. Even there is a unpaired electron, fine, but the domains formed, the domains prepared in a particular solid crystal, they are showing equal set of parallel and antiparallel, equal set of parallel and antiparallel domains. So whatever the magnetic properties arises due to parallel domains completely cancelled by anti-parallel domain. So the magnetic property actually remain cancelled because of the equal set of parallel and anti-parallel domains. So some of the substances like manganese oxide, manganese trioxide, manganese dioxide, ferrous oxide, ferric oxide, vanadium trioxide, chromium trioxide, nickel oxide. Some of the, you can see, some of the transition metal oxides behaving like this. Whenever these substances bring in a magnetic field, their domains set parallel, antiparallel, and no net magnetic moment arises. The zero magnetic moment arises. Even there is unpaired electrons, but the domains arises, the domains formed having a parallel, antiparallel set in equal number. So net magnetic moment become zero. And third possibility is ferrimagnetism. Perimagnetism. This is due to the random orientation of unequal orientation of domains. Unequal. For example, suppose one domain is parallel, so two domains are antiparallel, three domains are parallel, so two domains are antiparallels. So net magnetic moment will not be zero in this condition. So unequal number of orientation of parallel antiparallel domains which will not cancel completely the magnetic behavior of the substance. So a small net magnetic moment will be there, and there is also a large number of unpaired electrons. So all these three, ferrimagnetism, antiferro and ferromagnetism, they all three have an unpaired electron. So they are called paramagnetism. But the difference is the strongly attracted there is zero net magnetic behavior and there is small magnetic behavior because of the different types of orientation of domains prepared or formed in a solid state. So you can see, for example, Fe3O4, MF2O4, this is not F2, this is actually Fe2. This is actually Fe2. MF2O4, where M is a kind of metal, types of metal like a divalent metal, magnesium, copper or zinc, Mg plus 2, Cu plus 2 and Zn plus 2. The M may be Mg plus 2, Cu plus 2 and Zn plus 2. So ferrimagnetism means the unequal set of domains are formed when we bring a substance in a magnetic field, and due to which there is different orientation, the unequal orientation of domains causes small net magnetic moment. Even the large number of unpaired electrons are present. I am already told about antiferro, ferri and ferromagnetic behavior may change into the paramagnetic behavior at a certain temperature. For example, Fe3O4, which is ferromagnetic property, change into paramagnetism at 850 Kelvin temperature. For example, so in this lecture, we will dealing with the different types of magnetic behavior in the solid when they bring in a applied magnetic field or they already having that some type of magnetic behavior like a diamagnetism, paramagnetism. So overall, the diamagnetism means they are having only a paired number of orbitals and other four having a unpaired orbitals. Depending upon their nature in a magnetic field applied, they are showing different types of magnetic behavior, and this is all about what is the nature of the orientation of group of metallic positive sphere metallic ion. They call domains, and due to the different orientation of domains, they are said to be a different magnetic behavior. You have to learn the diagrammatic representation of these three with example. The transition metal oxide and their examples is very important. You can see the examples are there. So note down all the examples given here. This is all about this chapter. Now we'll discuss about some important questions provided in board, asked in board exam from NCERT exercise. NCERT example are in text. In the next lecture, then we'll start solution chapter. Then we'll start a solution chapter. Okay. So from Monday onward, we'll start a solution chapter. Next lecture will based on a question numerical concept of this chapter. If there is any other further doubt, that also we'll discuss. So try to be send a comment in a comment box. We'll discuss about that also. If there is any doubt or a question, send me after the lecture, and we'll discuss that topic, that question also in a next lecture. Okay, thank you.